period now. But I thought let's do this as the first thing in the morning because this was left in your linear programming problems. So bigger method FLPP maximize z equal maximize z equal to x1 plus 2x2 plus 3x3 minus 4x4 x1 plus 2x2 plus x3 plus x4 equal to 10. uh, x1 equal to 2x2 plus x1 plus 2x2 plus 3x3 equal to 15. 2x2 plus 2x1 plus x2 plus 5x3 equal to 20. So yeah, the common point of confusion is that mostly in big MLPP we deal with greater than, less than, but we rarely encounter equal to signs. There are everywhere in every equation in this question. There is equal to equality. That's a problem because then rules differ. So I have to show you how things work. See, if there is a greater than symbol, okay, to balance it, right? Like an equation is smaller than the RHS, right? Then if we add something, then that equation would be equal to this because it would become greater, so it would be balanced, right? So we add a big variable, slack variable, okay? We add the slack variable. And when it is greater than, like uh, mm, like the LHS is equal greater than RHS, then we take out S slack variable, so that it becomes smaller, okay? So that because a big thing, then you take a chunk out of it, it becomes smaller. Then it would become equal to the smaller thing, right? So yeah, LHS, bigger LHS would become smaller and become equal to RHS when we reduce S. And when we reduce S, we just add a small artificial variable A. So since this is not that significant artificial variable, when it is equal to, we add A because it won't change anything. So yeah, and in each iteration we actually reduce a, like one a would be reduced every time, okay? So I hope you understand this logic. Now we are going for this, okay? Z equal to x1 plus 2x2 plus 3x3 minus 4x4 plus wait a second, sorry, minus ma1 minus ma2 minus ma3, okay? Since you can see three equations which have equality symbol, so they all three would have a. And when you have a, like whatever variable you have, you put it in z equation. Like in other equations, whatever variables are there, you add those all to z variable, right? So uh, here we have a artificial variable. So we multiply artificial variable with m minus m, okay? Yeah. So we multiply artificial variable with m. We don't multiply anything with slack variable, but we multiply m with a when we are subtracting, okay? Now first equation, x1 equal to 2x2 plus 3 x1 plus 2x2 plus 3x3 plus a1 plus 0a2 plus 0a3 is equal to 15. Like see, like there are we have to fill in the table for all the variables. So there are gonna be three a variables because of three equations. So but only this is first equation. So only one a1 would only one a variable would be there, which would be a1. Others won't be there, but we have to fill the table. So we can put 0 in there because 0a doesn't make anything because it eventually makes 0 only. So nothing and 0a is same thing. So we are changing nothing, but we are filling the table. So let's go to the second equation. 2x1 plus x2 plus 5x3 equal to 20. Okay. Sorry. Plus 0a1 plus. So whichever equation it is, that a would remain, other a would be 0. Okay. a2 plus 0a3 is equal to 20. Okay. Now 2x, sorry, x1, no? Sorry. x1 plus 2x2 plus x3 plus x4 plus, oh sorry, if there are x4 I should have added x4 everywhere. Okay, let's do this. Others don't have x4, so it is 0 x4, simple. 0 x4 plus, yes, now x4 plus 0a1 plus 0a2 plus a3 equal to 10. Here we are. Now it would be simply like a simplex tableau. Okay. Yeah, like this would be variable area, this would be z, and wherever there is a. Okay. Oh, I forgot to do one thing. I have to show you another thing, right? So in place of this ma, we can substitute a with this equation. Like, let me show you. If this is the equation, right? What if this a goes here and this comes here, right? Let me show you. Let me show you. Yeah. Focus on the first equation. This a1 goes here, then it becomes minus a1. This 15 comes here, minus 15. Let me show you. Minus a1 is equal to 0 x4 plus x1 plus x2 plus 3x3 minus 15. We don't need other artificial variables here, but yeah. Oh, we need them actually. Forget it. Yes. See, isn't it same? And where is minus a? Here, right? Minus ma1. Then minus a would turn into this. Then it would be plus m into this equation because minus and ma is substituted here. Okay, minus a is substituted here. So only m would remain and it would be multiplied with this a substituted equation. And you have to do it with every equation. Like see, this a2 goes here, 20 comes here, minus a2 equal to this equation. Then minus a3 would be this equation. So you get it, right? So let's get on with it. Let me show you or else. I have to do it with everything. Let's show you. Minus a2 equal to, see how this equation, see this equation, this one. Minus a2 equal to 0x4 plus 2x1 plus x2 plus 5x3 plus 0a1 plus 0a3 minus 20. Yes. Now minus a3 would be, see here, see this equation. X1 plus 2x2 plus x3 plus x4 plus 0a1 plus 0a2 plus a3, sorry, a3 I've taken out, minus 10 actually, minus 10. Done. And we are done with this. Now, after we substitute this in this equation, we would take it this side, okay? Done. So, this should be ink got over. I might need to change my markers. I don't know why today no one is coming, but yeah. Z minus x1 plus minus 2x2 minus 3x3 minus 4x4 minus plus m. Wait a second. This will be plus m or minus m. Tell me in the comments. Yeah, this will be minus m because it transposed here, right? Minus m. 0a3 3x3 plus 2x2 plus x1 0x4 minus 50. Go. Then minus m a2 would be 2x1 plus x2 plus 5x3 plus 0x4 plus 0a1 plus 0a3 minus 20. Okay, then minus m for a3 we have x1 plus 2x2 plus x3 plus x4 plus 0a1 plus 0a. Wait a second. This marker is also dead. I have to find another one. Okay, this is not opening. Kindly wait a second. My hands are breaking, but this marker isn't opening. Holy crap, this marker. Sorry for the inconvenience. Wait a second. Yes. And we did this. Open the marker. Yeah. 0a1 plus 0a2. Where were we? Yeah. Minus 10. Okay. Minus 10. Yeah, other equations are as it is. Now for time for the simplex tableau. Okay. Variable z a1 a2, because where there is artificial variable we don't write slack variables, we instead write artificial variables. Okay, yeah, x1 x2 x3 x4, we write all the variables here, even the artificial ones, a1 a2 a3 a4. By the way, this is equal to 0, huh? This z equation is always 0, is equal to 0. Okay, this is always equal to 0. RHS. Okay, A3 only. Here RHS and ratio. Simple. Now it's totally like simplex table, simplex LPP. Okay. Now Z has a C here. Okay. Okay, I guess we had to solve it further, right? Okay, now we are in trouble. Let's solve it further, I guess. Ouch. Yes, let's do that. Oh no, this marker can't die, man. You can't do this marker. Z minus. Wait a second. X1. Oh boy. This marker went off. X1 minus 2x2 minus 3x3 minus 4x4 minus m. Wait a second. Yeah. M. I need to turn on fan. My voice might come low, but I have no other options. I have to turn on fan because no marker is being able to work. Let me check out some other marker if they can be useful. Yeah. M M into 3x3 plus 2m x2 plus mx1. Oh, sorry, not plus, huh? It would be everything would be multiplied by minus because minus was multiplied in the bracket everywhere and everyone is positive, so they would change signs into negative. Okay. Wait a second, huh? Uh, so yeah, minus 2x2 where is minus mx3? Wait a second. Yeah, minus x2. Okay. Wait a second. Minus 15m, right? Minus 15M. I feel like it should be on the right. RHS. Oh yeah, let's just keep it on the RHS. Yeah, why not? Yeah. I would add later then. Okay, this is not a variable. Why should we keep it here? Then this marker got troubled, bro. Nah, bro. Every marker is becoming useless right now. Oh my gosh. MX1. Right. Then it would be minus 2mx1 plus sorry, minus bro, everything is minus now. mx2 minus 5mx3, because they are positive and now they are on opposite side, they would be negative. Simple. Plus 0mx4. We didn't do mx4 here, right? Okay. Oh no, we did it. See. Okay. X4. So now minus. Wait a second. This marker is also dead. Is it visible, right? Yeah. Minus mx1 minus m 2x2 minus mx3 minus mx4, right? Minus mx4 is equal to, now put all the RHS terms like constants on the right hand side, okay? 15m plus wait a second, minus 15m, right? Minus 50, no, plus 15m becomes minus 15m, sorry. Yeah, this should become minus 15m. Huh? Wait a second. How is this happening? Okay. Okay, cool. Minus 15m minus 20m minus 10m. Okay. Yeah. Now we have to fill in the areas. No. First we have to solve it, right? Like bring like terms together, like x1 terms together. Okay. Okay. Let me show you. Is equal to. First, do you see the equation that I'm solving? Yeah. Now this should be x1 minus 3. No. Minus mx1 minus 2mx1 and minus mx1 again and again. It's mx1. Ha. Okay, this is like this: x1 minus mx1 minus 2mx2 minus mx1. Then we have to do, so x would be common and whatever is in this, that would be there. Okay, like let me show you. Okay, This should be common. Then 1, wait a second, x1 taken common outside. Then this should be 1 because only x was there. This should be m, 1 minus m minus 2, 2m because m was there, x we taken out. Why we are taking out x? Because we have to fill in x table, okay, not mx table. So m would remain, okay, minus m, okay. This is how it looks, okay. Similarly, uh, we have to only take out the variable part outside taking common. Then inside we have to write all the coefficient they have, okay. We have to separate the coefficient and the variable x. That way we can fill the table easily. So I would directly now do it, okay. So I have this marker, man. Wait a second, let me change marker. Let me change markers. Yeah. So minus. First I would take x2 common, then it would be 2 because it is 2 x2. Since it is 2x2, so except 2, there is no other variable other than x variable. So yeah, only 2 remains. Minus I've taken outside common, so it would be 2. No, let's just keep minus 2 because I have to fill that too, right? Can't ignore it. This is not working, man. This marker. Okay. Plus x2 minus 2, okay. Then here see minus 2m x2, then again minus 2m, right? Because if you take out x2 then only minus 2m remains, right? Then minus m, see here minus mx2, then x2 removed, only minus m remains because we took it out common, divided it, and and multiplied it outside. So yeah, so it will later multiply inside and become the same thing, so no change occurred, okay. Then minus this is also dead now. Okay, it has some life till now. Minus 2m, see, minus m into 2x2, remove x2, it becomes minus 2m, minus m2, but m2 is nothing, so minus 2m it remains, okay. And here we go. Then oh no, this is minus 1, not 1. This marker is also really cooked, bro. I have to find another one. This is more cooked. Only have this as last resort, so it might not be visible, but at least it has some ink. Z, I hope it is visible. Z plus x1 whole bracket minus 1, okay, minus 1 minus m 2m, okay, you got it right. Then put this in bracket, Like minus 2m was the last, right? Yeah. Then we come with x3 because we want positive x values. There is no negative x values to put in, right? If there was this was negative x1, negative x2, then would have taken negative x common, and whatever would have remained would be there, because we have to take negative x variable, but here we have to take positive x variable, so we would keep positive x outside and whatever remains would be inside. Okay, so that we can put directly the values. Okay, for x3 we have uh, minus 3 x3, so minus 3 because x removed, then minus 3m because why not, I mean minus 3m x3 it is, m is multiplied inside, so minus 3m x3, x3 removed, then minus 3m remains, then we have minus 5m if x3 is removed because it is minus 5m x3, then we have minus m because it is minus mx3, so x3 removed, minus m remains. Now time for x4 action. x4, first it is minus 4, then it comes minus okay, what, wait a second, hold on, why there is no mx4, hold on, okay, let's just write here, plus minus, right, yes, minus m 0 x4, but anyways it would be 0, but yeah, minus 4 plus or minus 0 doesn't matter, 0 0m is still 0. Okay, then a second one is also 0 m, who writes m, come on, then it would be minus mx4, here it is minus mx4, so minus m comes when we take out x4, minus m is equal to whole RHS 15m minus 20m minus 10m, and we are done here with the equation stuff, right? Wait a second, let me cross check. Yes, we have a 0 x4 here, 0 x4 here too, only 1 x4 here, so yeah, it is how it is. So now we have to fill in z, so z variables are here, write the coefficient simply. In x1 it is kind of big, so we need a big area, but we don't have. M minus 2m minus wait a second, okay, 1 minus m minus 2m, okay, wait a second, there is bracket missing. 1 minus m minus 2m minus m, 1 minus m minus 2m minus m, we have to fit it in this small area. Oh boy, oh no, yeah, let's give some space to this. A1, A2, A3, okay. One minus m minus 2m minus m. 1 minus m minus 1 minus m minus 2m minus m. Simple. Okay. Minus 1 minus m minus 2m minus m. Now, by the way, RHS is 15 m. Wait a second. Why? Minus 15 m it should be. Yes, minus 15 m. Minus 15 m. Let me write it. Minus 15 m. Minus 10 m. Minus 20 m. Simple. Not simple, but yeah. This is how it is. X2 is, see, x2 is here. Minus 2 minus 2m minus m minus 2m. See, minus 2 minus 2m minus m minus 2m. Okay, might get confused, so let's put a line here to not go out of line. So x3, for x3, this whole, okay, minus 3 minus 3m minus 5m minus m. Minus 3 minus 3m minus 5m minus m. Okay, and we draw a line here. Wait a second, it's a curve more than a line. Forget it. For x4 we have minus 4 minus 0. Let's write minus 4 minus m. Okay, minus 4 minus m. Simple. And other a1 a2 are in this. A1 a2 are all 0, I guess. Yes. Wait a second for me. Wait a second for me. Yes, they were all 0. Let's just simply write them 0 0 0. Okay. Now let's predict which is the key column. Okay, so we have to, for predicting a column, we check a row, because row is a horizontal thing. So we take a element, then take its vertical column, right? Because a row shows different columns, we get to choose columns. So you take z row to choose columns, right? The most negative would be key column. Okay, most negative z element. Minus 1 minus m minus 2 m minus m. We can take m here common, right? Wait a second. Minus m minus 2m minus m. It would be minus 3m. What are we doing, bro? Isn't it? Oh my god. We can just operate it here, right? Minus 3m minus 1. Simple. Then minus 2 minus 2m minus m minus 2m. It would be minus 5m. Minus 5m minus 2. Wait a second. Minus 5m minus 2. Now we're talking. Wait a second. Is it visible? Camera is blurry, I guess. Now focus is there, yeah. Minus 3 minus 3 minus 5m minus m. So it would be minus 8m minus 9m. 3 minus 9m. Minus 3 minus 9m. Wait a second. Minus 3 minus 9m. Then minus 4 minus m. Then 0 and stuff. Wait a second. Minus 15m minus 10m minus 20m. This can be also added, right? Like minus 15 minus 10 is minus 25 minus 25 minus 20 minus 45m. Let's go. Minus 45m. Simple. Now the most negative we can see, there is like variable is can take any form. So it would be multiple of something bigger. So Variable is always greater because variable can take any form greater than it, and it can multiply into way greater form, right? Constant is just constant, it would remain how it would be, it won't get multiplied, but a variable would be multiplied to some coefficient. Okay, so variable is always greater. So there is minus 9m. Bro, 3m is smaller, 5m is smaller, minus 9m is greater, most greater here. Minus m is all very small, and RHS we don't need to see, I guess. That's 45m. Wow. Okay. So minus 9m is the greatest. Uh, minus 3m, right? Minus 3 is very tiny in front of these. Come on, bro. So you would take it as key column. Okay. Our key column. Now, let's substitute other things like A1, A2, A3. So yeah, we have to also divide this key column to RHS. So let's do this 45 minus 45m, right? Minus 45m by minus 9m by minus 9m minus 3. Simple. So for A1 we have A1 equation we have 1 1x1 2x2 3x3 0x4 1a1 0a2 0a3 here 15. Okay, RHS is 15, here it is 20, here it is 10. Simple. Then there is wait a second, let me see. 2x1 1x2 5x3 0 no, yeah, 0x4 0a1 1a2 0a3 equal to 20. Then we have 1x1 2x2 1x3 1x4 0a1. Let me extend the table. 0a2 1a3 equal to 10. Okay, now 15 are in RHS divided by 3 in key column, so it would be 5. 20 divided by 5 is equal to 4. 10 divided by 1 in key column, RHS 10 divided by key column 1 is 10. Simple. Okay, and here is our first iteration complete, but we have to find uh, least positive value. So this is negative, out of the question. Least positive value is 4, so we have to take this as key row. Okay, key row, here we are, this is key row. Now key row and key column intersect at 5. Okay, 5 is the key element. We have to do star actually, but whatever. Yeah, then we have to divide this key row by this key element. Okay, I'm gonna erase this, so please note it down if you are noting this z equation solving. Okay, or take some screenshot or something if you have, but there would be many screenshots, so please just note it. Wait a second, let me erase. You're seeing this. And here we are, cleaning the arena. And we're done with it. Now whole key row would be divided by 5, so that this key element becomes 1 to give unitary matrix. Let's go. Let's just write it as it is. No. Only key row would be written as it is. 2 by 5, 1 by 5, 1, 0, 0, 0, 1 by 5, 0, 20 by 5 is 4, 4. So RHS came here, right? Now using this new new row made by key row, we have to do row transformation that other elements of key column in every row becomes 0. Okay, obviously except the key element one, so that we get unitary matrix. And also these would exchange, right? Yeah, this should become x3. This should become x3. Wait a second, where it is? Yes, they would swap places, and not exactly swap, only the key column name would come to key row name. Okay, now this new row we have to think about row transformation making other 0. So let's think about row 1. 2 by 5, how to make it 1? Let's think. So 2 into let's do 2 into 5 by 2, right? 2 by 5 into 5 by 2, it would make it 1, right? So if we multiply the reverse thing, they would cancel out and become 1. Simple. So we have to make changes in R2 is R1. Since they are same sign, to make them clash, we have to make them opposite signs by subtracting them. Subtracting them makes opposite signs. Okay. Uh, no. Wait a second. No. We have to make this 0, not this 0. Using this element, using this new row key element 1, we have to make this key columns element 0. No. We were totally taking wrong path, but yeah. So 1 into 3 is 3. Okay, 1 into 3 is 3. But these are same sign. So how to make them clash? Reduce this to 0. We would make it opposite signs by subtracting. Okay. So R2 is this is row 2. Row 2 is equal to row 2 minus 3R3. 3R3. 3 into R3, right? So whole row would multiply by 3 and reduce R2. See, like 3R3. 3 into 1 is 3 and 3 minus 3 is 0. Okay, let's go with that. 0. 3 into 2 is 6. 6 by 5 minus 1. Sorry, 1 minus 6 by 5. It would be 5 minus 6 by 5 minus 1 by 5. Minus 1 by 5. By the way, this is still a1. Okay. 2 minus 3 by 5. So 5 2s are 10. Denominator would multiply here because to make it same denominator so that they can operate. So 10 minus 1, 10 minus 3, because it is 3 or 3, right? 3 into 1 by 5 is 3 by 5. Numerator into denominator by denominator into denominator is how you multiply fractions. So yeah, 3 by 5, 2 minus 3 by 5 would be 5 2s are 10, 10 minus 3, 10 minus 3 7, 7 by 5, 7 by 5. Okay, by 5. Now 0 into 3 would be 0. 0 minus 0 would be still be 0. 1. right? 0 into 3 would be 0, 1 minus 0 is still 1. And wait a second, where were we? Yeah, 0 0 1 0. Then we are here at 1 by 5, so it becomes 3 by 5 because we multiplied by 3. 3 by 5, so 0 minus 3 by 5 is minus 3 by 5. 0 minus 3 by 5 is 3 by 5 minus 3 by 5. Okay, then we have here 0 minus 3 into 0 is 0. 0 minus 0 is still 0. Here we have 15 minus 3 into 4. 3 are 3, 3 into 4, 15 minus 3 into 4. 3 into 4 is 12. 15 minus 12 is 3. Here we are. Then we have to make uh, this third row as 0, I guess. So what do we have to do? This x3 it has 1. 1 minus 1 would be 0. So just same number, so don't need to multiply anything, and only opposite sign, so we have to make it clash by making it opposite sign, which is subtraction. So r4 is r4 minus r3, just make them clash, simple. Just do minus. Okay, a3 now. Okay, 2 by 5, 1 minus 2 by 5, right? First things first, this would be 0. 1 minus 1 would be 0. Obviously we're trying to do the same thing, so it would be 0. So uh 2 by 1 minus 2 by 5 is 5 ones of 5. 5 minus 2 3. 3 by 5. Have fun. 3 by 5. Then we multiply this denominator into this, because this is a whole number, so denominator is the whole part. So we multiply the denominator, the whole part, into this whole number because it is a whole number. Then we operate the fraction because that whole number came in terms of this fraction. So yeah, whole number is always multiplication of some denominator when it is compared with a fraction, because denominator shows the whole thing. Okay, whole, how many pieces are there in that whole part. Okay, 1 by 5 minus 2 minus 1 by 5. 5 2s are 10. 10 minus 1 9. 9 by 5. 9 by 5. After that 0. 1 minus 0. This 1 minus this 0 is 1. This 0 minus this 0 would be 0. New key row, we have to come like operate with old rows to get new rows, so you have to understand that. Yeah, 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 1 by 5 would be 1 minus 1 by 5. Then 1 minus 0 would be 1. 10 minus 4 would be 6. Simple. Now we have to do with uh, like minus 3 minus 7, and I don't know how to do that. you know this is gonna be way too much complicated. Let me just think about it. See, like this is minus 9 minus 3m, right? Minus 9 minus 3m minus 3m minus plus, let's say, 5x. Okay, no, not 5x, bro. 1 into x, because new element is 1, right? X, yes, we have 1, right? So when x equal to 0, this is how you find things. Okay, So this is what we need, x, like what we have to multiply with 1, so that when add with this we get 0. Okay, then uh, x goes that side, minus x equal to minus 3 minus 9m minus 9 minus 3m. So negative gets cancelled everywhere, so it is 3m plus 9. Okay, x equal to 3m plus 9, because everything is negative, we cancel every negative term here to make it positive. We multiply whole equation by negative, so common factor is negative, so it is the same thing. But this negative makes every sign opposite. Every sign was negative, so every sign became opposite, which is positive. So now we got it. So we have to add 3m plus 9. Okay, 3m plus 9. R1 is R1 plus 3m plus 9 R3. Okay, here we go. Like let's see. Wait a second. Yes. This is 1. 3m plus 9 minus 3m minus 9 is 0. Wait a second. Z. So we got 0 here. Now 1 by 5 into 3 plus 3m plus 9. 3m plus 9 by 5. Okay, 3m plus 9 by 5 is added to, this is what where it is, yeah, to 5m minus 5m minus 2. Okay. Okay. So we would write this same as it is, because this is plus, so no sign changes. Okay, minus 5m minus 2. Are you sure this is it, right? 1 by 5, 3m by 5, and this. Okay, yeah. Now this would multiply here, 3m plus 9 minus 25m 5 has so it for this 5 would be multiplied by whole, because whole is whole number, right? So this would multiply to this whole thing, like this one time, this one time, it would get multiplied by both. Okay, so 5 5 is a 25 minus 5 2 is a 10, 5 2 is a 10. Okay, minus 10. Now we would minus this, then it would be first minus this, then this is minus 22m. 9 minus 10 is minus 1. 9 minus 10 is minus 1. So we got minus 1. We got minus 1 here. 22 minus 1. Minus 22 minus 1. Okay. So this would be minus 22 minus 1. Okay. Here we go. Now this is minus 3m minus 1. And here we have 2 by 5. So 2 by 5. Wait a second. Two by 5. 2 would be multiplied to the whole thing. Okay, 3m plus 9, which we took factor to make the 0. Okay, 2m by 5. 2 by 5. Okay, numerator into denominator. Since it is a whole number, it is only numerator, because we are taking all parts, we are leaving none. So we are taking multiples of parts, so this whole thing is numerator. So then below it 1 would come, because divided by 1 is multiplicative identity. So dividing it with 1, anything, it would be same. So yeah, it makes no changes, so it is like that. Like, it shows that it is one whole part, it is not divided when we keep denominator 1. So yeah, that shows it is whole part. So we also multiplied that below, above, so To balance it, then that multiplies, numerator into numerator, by denominator into denominator is multiplication of fraction. So we multiply two numerators. So this would be 2 into 3 would be 6. By the way, this 2 would multiply to both the terms, okay, whole thing. 2 into m is 6 plus 9. Then it would be 2 into 9 is equal to 18. 6m by 18, 6m plus 18 by 5 is this, which would be added to this. So it would be just subtracted because it is opposite sign minus sign, and since we are adding, no signs change, so they are opposite, so they would reduce each other. So this is 5. This would multiply to whole thing to make a common denominator, so we can operate. 3 5s are 15m minus 5 minus 6m plus 18 by 5. Okay, 6 minus 15 is minus 9m. Okay, plus 18 minus 5 is plus 13 by 5. Minus 9m plus 13 by 5. Minus 9m plus 13 by 5. Here we go. Now this is 0. Now this is 0. Okay, so anything we multiply to it, it would remain 0. So 0, and this is minus 4 minus m. Okay, so it would be 0. Wait a second. 0 plus 0 plus minus 4 minus m would be same minus 4 minus m. Okay, simple. Wait a second, let me write it a little, saving space for other things. I still wrote it weirdly. Yeah, minus 4 minus m. Now we have x3, other element is also 0, so 0 into anything is 0. So 0 plus 0 would be 0. See, here is also 0. This 0 plus this 0 into 3m plus 9, which is 0. So 0 plus 0 would be 0. Done. Okay. Now 1 by 5 into 3m. So 3m plus 9 by 5. 3m plus 9 by 5. 3m plus 9 by 5 plus 0. Here it is 0. Okay. 0 plus 3m plus 9 by 5. Minus 3. Here it is 3m plus 9 by 5. Okay. 1 by 5 into 3m plus 9. It would be 3m plus 9 by 5. And anything added to 0 would be same. So 3m plus 9 by 5. So we add 3m plus 9 by 5 to 0, so it would remain same, 3m plus 9 by 5. So now we have 0. Okay, 0 into anything is 0, isn't it? 0 into anything is 0. So since 0 into anything is 0, a1 is 0. Wait a second. Yeah. So this is 0. 0 into anything is 0, and here it is also 0. So 0 plus 0 is also 0. Now RHS is 4. 4 into 3m plus 9. So it would be 12m plus 36. 12m plus 36 minus 45. Since this is minus 45m, so it would be minus 45m plus 12m plus 36. So 45m minus 12, right? So this would be 33m. Okay, this would be minus 33m, right? So this is minus 33m minus 36. Here we go. So you have to make iterations like that. It would continue very long. So yeah, it's not gonna get over, because when either everything is positive here or everything is negative here, Till then you can continue the operation till this all becomes a3. Like one time this swapped, right, this become from a3 to a2 to x3, then another row becomes key row. Every row one time it became key row, then they would be replaced by these variables. When every a is replaced by variables, then your sum is also finished. And if these become negative or these become all positive, then also sum is finished or infeasible. So yeah, now you understand how to then you have to just do iterations. So similar iterations you have to do it again. Like in this new table you have to find the same key row, key a column with positive, like you have to this is RHS and all. Then you have to write ratio here, like take key column by most negative value here. Variable is always greater, okay. So most negative value key column divided by RHS, get ratio get key row by whichever is very smallest positive number. Then they intersect into key element divides the whole. Then you have to take that new divided key row. Then you have to change the row transformation, change other key column elements to 0 by doing row transformations with old rows from new key row, okay. So this is how it is. This is how it is. So okay, everything should be there is a ratio, there is RHS and all that. I don't know what else to say. Z should be all positive to end, and RHS should be all negative. Ratio should be all ratio, not RHS. Ratio if all positive, negative, then the sum is also over, or else this all should replace. Then x1 x2, the whatever is in table, like here x3 and x3, like wherever row and column intersect which element, that would be solution of that. Like here it is x3, let's say here it is x3. So x3 from here coincide here, intersect here, so this element is x3. Like you got it right. So this is how you do it. So let me zoom out so that you can take the screenshots. I hope you took the screenshots. So thanks for watching. Like, share, subscribe. See you next time. Bye bye.